Hey there. Today we're going to talk about open and short circuits in a series circuit. Okay, so we're going to start with a couple of reminders. One is that the resistance of a wire or a conductor theoretically is zero. Okay, so we're going to go on that assumption for this lesson, that the resistance of a wire is 0 ohms. The resistance of open air is infinite. Okay, so we're just going to go on those assumptions. So when you have your meter leads together, they will show 0 ohms. And when you have your meter leads apart in resistance mode, you will see infinite resistance. All right. So what we have here is just a regular series circuit with E, R1, R2, and R3. All right. So what happens is in normal operation, okay, RT is equal to R1 plus R2 plus R3. Okay. IT is equal to E over RT. And then E is equal to VR1 plus VR2 plus VR3. Okay, that is a normal operation. If we short out one of these resistors, okay, so let's just redraw this circuit quickly. We have E, R1, R2, and R3. So we're going to short R2. What a short circuit is a 0 ohm bypass of a load. Okay, so what that means is when IT hits that point, it is going to go through the short instead of through R2. Okay, so theoretically, all the current goes through the short, all of it. Which means now, when we short R2, okay, when we short R2, so this is 0 ohms and this is whatever resistance it is, all right? Hence the saying, taking the path of least resistance. This is the path here of least resistance, 0 ohms. So what happens now is RT is now equal to R1 plus R3, okay? Because R2 now is equal to 0 ohms. R2 is out of the picture, okay? So now, if RT is now equal to R1 plus R3, that means that RT went down. If IT went down, that means that if RT went down, that means IT went up, okay? And if IT went up, that means that if this is shorted, okay, since VR2 is equal to IT times R2, and R2 is equal to 0, right? That means we have VR2 is equal to 0 volts. Because if you took the voltage across a wire when it was in the circuit, it would be 0 volts because the resistance is 0. Which means now that E is still equal to VR1 plus VR2 plus VR3. Kirchhoff's voltage law does not change, but now it's equal to VR1 plus 0 plus VR3. So that is what happens in a short circuit when we short a load in a series circuit. Okay, it's a different story in a parallel circuit, but in a series circuit, this is what happens. We short out R2, R2 now becomes 0, RT becomes R1 and R3, okay, and IT goes up. So now, let's do an example here. We have this circuit, okay? We have this circuit. So normal operation. Normal operation, okay? We have that RT is equal to R1 plus R2 plus R3, which is, there is no R3, sorry. It is 140 ohms, okay? Well, I'm such a habit of doing R3. IT is E over RT, which is 20 over 140, okay? Which equals 142.857 milliamps. I always show the calculator on the screen when I'm doing these because I still get students who are saying, how did you get that? So if I have the calculator on the screen, it's there for you to watch. Okay, VR1 is equal to R1 over RT times E, which works out to 50 divided by 140 times 20. So we get 7.143 volts. And then VR2 is equal to R2 over RT times 20, which works out to 90 divided by 140 times 20, okay? 12.857. So that is our circuit in normal operation. So now something goes wrong, okay? Unknown to us yet, but R1 has been shorted, okay? So this is what we end up with. There's R1. Okay, and E is equal to 20. So R1 has been shorted. Something happened and the load got shorted. So the short could be caused by a faulty component that may have shorted internally. It may be something, something disconnected inside whatever device, and a wire may have come loose and reattached itself on the other side of the load. Who knows? But shorts happen different ways. Okay, but in this case, R1 has been shorted. So this means that R1 is effectively 0 ohms. Okay, so RT now is equal to R1 plus R2, which is equal to 0 plus 90 ohms. So RT is 90 ohms. IT is now E over RT, which is 20 divided by 90, 222.222 milliamps, 222.222 milliamps, okay? And VR1 is equal to R1 times IT, which is equal to 0 volts since R1 is 0 ohms, and VR2 is now equal to IT times R2, which is going to work out to 20 volts. Okay, so that is what happened when we shorted one of the loads. Why do we need to know this? Why do we need to know this? Why do you need to know this? Because you always know how a circuit is supposed to operate. Okay, just like your mechanic knows how your car is supposed to run when everything's running well, you are supposed to know in advance what a circuit is going to do. This is why you do pre-labs when you're doing labs in school, to predict the results. So we have this, and now we're taking readings and we say, R1, VR1 is supposed to be 7.143 volts, but it's all dropped across R2. VR1 is 0, and VR2 is the whole 20 volts. What's going on? Is there any current in this circuit? And you see, and when we do open circuits, you're going to see why. You're going to see that there's 222.222 milliamps. So the circuit has not been broken, but IT is way higher than it's supposed to be. It's supposed to be 142, and it turns out that it's 222. So obviously one of our resistances has been shorted. Okay, and we can figure out which one by measuring across each resistor, and the one that has 0 volts is a short circuit. Okay, now we know it's a short because the circuit is still complete. There's still a complete circuit because we have a current. All right, that is a big thing. We have current, so the circuit is still complete. So that is a short across a load. Okay, remember, a short is a 0 ohm bypass of a load. Here's a load. Here is the 0 ohm bypass of that load. All of the current passes through there. Okay, that is a short circuit. Now, for an open circuit, this circuit here, okay, in normal operation, okay, we know that RT is equal to R1 plus R2 plus R3, which is equal to 3K. All right, we know R1 is equal to R2 is equal to R3. So we know that VR1 is equal to VR2 is equal to VR3, which is equal to 20 divided by 3. Okay, we're now experts in this, so we're going to go through that part quickly. 6.667 volts. Okay, and then IT is equal to E over RT, which is 20 divided by 3K. Divided by 3K. And there we go, 6.667. Now, an open circuit, okay? Let's say that something scraped your circuit board or accidentally hit one of the wires, and you now have an open between R1 and R2. All right, so let's just take this. We have that there. We now have an open circuit. So if you remember that the resistance of an open is infinite. Okay, so we still have to consider this a loop, and I'll show you why. Still consider this to be a loop. So now RT is equal to R1 plus, we have this in the loop now, R open plus R2 plus R3. Okay, which means that it is 1K plus infinite plus 1K plus 1K, which is equal to infinite. Okay, if IT is equal to infinite, if RT is equal to infinite, then IT is equal to E over RT, okay, is equal to 20 over infinite. And if you remember what we talked about, anything divided by infinite is 0. So IT is 0 amps. Okay. Now, some electrician is wondering why I am showing you all this math instead of just telling you the final answer. But there's a reason we do the math, because you need to work through things. When we get into series parallel, into parallel circuits, you need to know how the math works, okay? So we have this. Now, I told you to consider this a loop. If you remember Kirchhoff's voltage law, it would apply to this loop by saying that E minus VR1 minus V open minus VR2 minus VR3 is equal to 0. Okay? Because current is 0, okay, since IT is equal to 0, that means that VR1 is equal to 0 volts, because V is equal to I times R, and I is 0. Okay, V is equal to I times R, and I is 0. So all the voltages are 0. VR1 is 0, VR2 is 0, VR3 is 0. Okay, you need to remember that. So here's what we're left with. We are left with E, which is 20, minus VR1, which is 0, minus V open, minus VR2, which is 0, minus VR3, which is 0, is equal to 0. So that tells us that V open, the voltage of the open circuit, is equal to 20 volts. So in a series circuit, the voltage across an open circuit is equal to E. Okay? The difference between an open and a closed circuit, a short circuit, between an open and a short circuit is, in a short circuit, there is still current flow. In this short circuit that I showed you here, we still have current flow because we still have R2 in the circuit. This circuit, we do not. So if you took your voltmeter and you measured across R1, across R2, and across R3, you would get 0 volts. And if you measured across the open, you would get 20. So now, if you were a technician on site, what you would see is, you would see this circuit here, and something's wrong. Customer called you and said that my 3 resistor series circuit is not working. Can you please come check it out? And so you measure across E and you get 20. You measure VR1, you get 0. You measure VR2, you get 0. You measure VR3, you get 0. So now what you do is you would measure between E and R1, and you still get 0. Now when you measure between R1 and R2, now when you measure the connection between R1 and R2, you see that you get the full value of E, which tells you where the open circuit is. Okay, that is when there's an opening in the circuit. That's when there's an opening in the circuit. Okay, now, if you have a faulty component, so now what happens in this circuit is you don't know this yet, but R2 went bad on you. R2 went bad on you, okay? And so you need to identify which component went bad so you can get your 15-cent refund. So what happens now is, so now R2 is open. So defective, something happened to it, okay? Something happened to it and it just internally decided to retire. So what happens in this circuit is we have RT. So now R2 is now infinite resistance, okay? So now RT is equal to R1 plus R2 plus R3 which is equal to 1K plus infinite plus 1K, which is equal to infinite, which means that IT is equal to 0. Okay, so what happens now? We go around this circuit. IT is equal to 0, so VR1 is going to measure 0. VR1 is going to measure 0. Okay, VR3 is going to measure 0. And VR2 is going to measure E. That's what's going to happen here. VR2 is going to equal E, and VR1 and VR3 are going to equal 0. That is because the open circuit is inside R2. That's a very important thing to remember here. Now, how can you tell the difference? Do you have an open circuit? Do you have a short circuit? What about this? How do I know if I took this short circuit I showed you before? Well, I have 0 here and I have E here. How do I know if R1 is broken or shorted? Sorry, how do I know if R1 is shorted or if R2 is broken? And the way you can tell is this. You still have current. You still have current. There's still a path for current to flow here. Okay, here, there's no current. There's no current in a broken circuit. There is current when one load in a series circuit is shorted. Okay, so what happens here is that your current, you were expecting, in a short circuit, you were expecting a certain current, that current went up. Okay, in a circuit that has an open, you were expecting a certain current. Okay, we were expecting 6.667 milliamps, and we end up with 0. The fact that we end up with 0 means something is open somewhere. All right, that is the difference between a normal operation, a short-circuited load, and an open in the circuit. So I hope this explained it a little bit for you. I hope you found it useful, and thanks again for watching.